Okay, sampling distributions of a difference in sample proportions. So it says, why do we have this? Creating a sampling distribution of a difference in sample proportions will set us up for success when we start studying inferences in Unit 6. These sampling distributions can be used to answer the common question of which is better. For example, it says which of the two popular drugs, we'll say L or P, help lower bad cholesterol more? Researchers used 4,000 people with heart disease as subjects in a completely randomized experiment. They were randomly assigned to one of two treatment groups, one L and one P. At the end of the study, researchers compared the proportion of subjects in each group who had died, had a heart attack, or suffered other serious consequences within 2 years. For the subjects assigned to P, 0.263 suffered a serious consequence, and for subjects assigned to L, 0.224 suffered a serious consequence. Does this mean that L is better at lowering bad cholesterol than P? Is this difference a result of L being better, or is it merely due to chance involved in a random assignment and treatments? Answers to these questions require a sampling distribution of a difference in sample proportions. So it's not enough to say, well, L has a lower probability than P in order for it to say it's better, because that probability and significance of it is very, very, very small. Okay, we're talking about 22% compared to 26%. So let's first recall and remember sampling distribution of P hat. So we know that the shape is going to be approximately normal, and we know it's going to be approximately normal as long as we satisfied the large counts condition. We know the center is going to be mu of P hat equal to P as long as we have random something, random selection, random assignment. And then lastly, spread, we know that standard deviation of P hat is equal to the square root of P times 1 minus P over N as long as the 10% condition is met. Also recall combining random variables. We know the shape of combining two or more normal distributions will result in a normal distribution. We also know that if we were adding or subtracting the center, then we can typically just take each of the distribution center and add or subtract them. And then for spread, for standard deviation, variances are always added. So we're always going to add no matter if we're adding or subtracting. Now talking about a sampling distribution for P1 hat minus P2 hat. So let's start and let P1 hat be the sample proportion for the first group and P2 hat be the sample proportion for the second group. Our shape, we still want to be approximately normal, but not only do we have to meet the large counts condition for P1 hat, we also have to meet it for P2 hat. So that is, we have N1 times P1 is greater than or equal to 10. N1 times 1 minus P1 is greater than or equal to 10. N2 P2 is greater than or equal to 10. And N2 times 1 minus P2 is greater than or equal to 10. All of those have to be satisfied. Okay. We also know that mu of P1 hat is equal to P1, and mu of P2 hat is equal to P2. So mu of P1 hat minus P2 hat is going to equal P1 minus P2. Again, that is as long as both are random. So both P1 and P2 have to be random, either randomly selected or randomly assigned. And then lastly, spread. Well, we know that sigma of P1 hat is going to equal to the square root of P1 times 1 minus P1 all over N. And sigma of P2 hat is going to be equal to the square root of P2 times 1 minus P2 all over N2. Sorry, forgot the subscripts for the N. And if we were to subtract them, that's the same as squaring each of them. and adding them together, which means that the sigma of P1 hat minus P2 hat is equal to the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2. And this is only going to be true as long as the 10% condition is met, and it has to be met for both sample sizes and population size. So N1 has to be less than or equal to 10% of N1, and N2 has to be less than or equal to 10% of N2. Okay. So to answer the original question, if there is a difference between L and P, we need to know a little more about hypothesis testing. For now, let's look at an example involving finding probabilities of a difference between population proportions. So we have one example here, and it says a recent study examined the percentage of young adult women and men who get less than 7 hours of sleep at night. Notice this is similar to an example we did prior, but we only talked about young adult women. In this study, it was found that 45% of women and 38% of men get less than 7 hours of sleep a night. What is the probability that a random sample of 50 women and 75 men will result in a difference of 15% or more between the two groups? So our first step is to communicate, and that is to label what our two proportions are. So we have the proportion, or PW, which is going to be the proportion of women who get less than 7 hours of sleep. And then PM, which is going to be the same thing, but for men. And we are trying to find the probability that proportion of women minus the proportion of men is greater than or equal to 0.15. Okay, because it says will result in a 15% difference. So greater than 0.15, but then we have to also talk about the probability of PW minus PM less than or equal to negative 0.15. So what we're looking at here is we're looking if we were to add 15 on either side. That's why we have a positive and a negative value. Okay, for the create part, remember we have to answer if it's random, independent, and normal. So for random, okay, both are random samples. So we know that mu of P1 hat minus P2 hat is equal to 0.45 minus 0.38, which is 0.07. Then we have to do independence. And remember, for independence, it's the 10% condition. And we have to check it for both. So we have 50 is less than or equal to 10% of all young women. And 75 is less than or equal to 10% of all young men. Okay. Since these are safe assumptions, then we can find our standard deviation. So standard deviation of P1 hat minus P2 hat is equal to the square root of 0.45 times 1 minus 0.45 over 50 plus 0.38 times 1 minus 0.38 all over 75. And that gives us 0.0900. And then we have to prove that it's normal. And we do that by using the large counts condition. So we have to say that 50 times 0.45 is greater than or equal to 10. And 50 times 1 minus 0.45 is greater than or equal to 10. And 75 times 0.38 is greater than or equal to 10, and 75 times 1 minus 0.38 is greater than or equal to 10. Okay, since these are all true, we can imply that the combined distribution is approximately normal. Okay, now that we proved all that, we can do the calculate part. So for the calculate part, what we're trying to find is both of those probabilities that we stated in the beginning. So we have the probability of PW minus PM greater than or equal to 0.15, and the probability of PW minus PM less than or equal to negative 0.15, where PW minus PM follow a normal distribution of mu equal to 0.07 and sigma equal to 0.09. Okay, so I'm going to go to Desmos. I'm going to add an inference probability distribution, and on normal distribution, I'm going to make sure I include my mu and my sigma. I'm going to click on the drop down, and since I want to find two different ones, I'm going to have to do two different answers, get two different answers. So greater than or equal to 15, so that's right. So 0.15. So for this one, I get, this one is equal to 0.187. And then I need less than, so I'm going to change it to left, and then I'm going to change this to negative. Okay, and then so for this one, I get 0.007. Okay, so I can now get rid of that. I don't need this anymore. And then for the last part, I just need to write my sentence. So the probability that a random sample of 50 women and 75 men will result in a 15% difference getting less than 7 hours of sleep is between is not is in between. Okay, is about 19.43%, because what we need to do for each of the values that we got is we need to add them together. So 0.187 plus 0.007 is about 0.1943, or approximately 19.43% chance that a random selection of 50 women and 75 men will result in a 15% difference getting less than 7 hours of sleep a night.